Ever pondered why comets, those celestial wanderers of our solar system, are often associated with omens and prophecies? These cosmic snowballs with their fiery tails have sparked curiosity and fascination for as long as humans have looked to the skies. The term comet comes from the ancient Greek word cometus, meaning long-haired, a fitting description for these objects that seem to sport flowing locks of ice and dust as they streak across the night sky. Throughout history, different civilizations have attributed various cultural and scientific significances to these celestial bodies. From the ancient Chinese, who meticulously documented their appearances, to the Egyptians, who believed them to be the souls of gods, comets have always been more than just astronomical phenomena. In the realm of science, they've served as celestial timekeepers, their predictable orbits allowing us to measure time and space. Today, they continue to captivate us as we strive to uncover their secrets. A comet's journey is not just a spectacle, it's a story of our solar system. But what exactly are these heavenly bodies that streak across our skies? Let's delve into the anatomy of a comet and find out. At the heart of a comet lies the nucleus, a solid core typically a few kilometers wide. This nucleus is like a cosmic snowball, composed of a mixture of rocky material, dust, and water ice. It's not unlike a dirty snowball you might make in your backyard, only on a much grander scale. Encasing this nucleus is the coma, a glowing envelope of gas and dust. The coma forms as the comet approaches the sun, and solar heat begins to sublimate the ices within the nucleus. These ices transform directly from a solid state to a gaseous state, bypassing the liquid phase altogether. The result is a cloud of water vapor, dust and gas that can expand to a size larger than even the most massive planets in our solar system. Now let's talk about the comet's most distinctive feature, its tails. Yes, you heard that right, tails, plural. A comet typically has two tails, a dust tail and an ion tail. The dust tail, which is usually the brighter and more visible of the two, is composed of tiny dust particles that are pushed away from the sun by the pressure of sunlight. This tail tends to follow a curved path, tracing the comet's orbit. The ion tail, on the other hand, is made up of charged particles or ions. These ions are blown directly away from the sun by the solar wind, a stream of charged particles flowing out from the sun. As a result, the ion tail always points directly away from the sun, regardless of the comet's direction of travel. So the next time you see a comet streaking across the night sky, remember this. You're not just looking at a dazzling light show. You're witnessing an icy dust ball hurtling through space, burning bright as it nears our sun. In essence, comets are icy dust balls hurtling through space, burning bright as they near our sun. So, where do these celestial nomads come from, and what sends them on their fiery journey across our sky? The birthplace of these celestial wanderers is often the farthest reaches of our solar system, in areas known as the Oort cloud and the Kuiper belt. These regions are like cosmic nurseries, teeming with icy bodies that have the potential to become comets. The Oort cloud, a sphere of icy objects, envelops our solar system, lying almost a light year away. On the other hand, the Kuiper belt, a disc-shaped region, resides just beyond Neptune's orbit. Now, imagine these icy bodies living peacefully in their distant homes. Suddenly, a gravitational nudge, perhaps from a nearby star or the galactic tide, sends them hurtling towards the inner solar system. This is the start of their epic journey, a journey that will transform them from icy bodies into fiery, glowing comets. As they approach the sun, these icy bodies, now comets, start to heat up, shedding layers of ice and dust. This process creates the comet's coma, a glowing envelope of gas, and its tail, which always points away from the sun due to the solar wind. This is the moment when a comet truly comes alive, dazzling us with its brilliance. Now, what about their path through the solar system? Comets travel in highly elliptical orbits, unlike the more circular orbits of the planets. This means that their speed varies dramatically during their journey. They move fastest as they swing around the sun, a point known as perihelion, and slowest when they are at their farthest, the aphelion. Their journey is a dance with gravity, a delicate balance between the sun's pull and their own momentum. And it's this dance that determines whether they will return to the outer regions of the solar system, be flung out into space, or plunge into the sun itself. Comets are the silent travelers of our solar system, coming from the farthest reaches to pay us a brief but brilliant visit. Comets are not just dazzling celestial shows, they are keys to understanding our past. As we delve deeper into the realm of comets, we realize the significant role they play in the grand scheme of science. They serve as time capsules, preserving the primitive matter from which our solar system was formed over 4.5 billion years ago. Imagine holding a piece of history in your hands, a relic from a time when planets were just beginning to take shape. That's what studying comets feels like. They offer us a window into the past, a glimpse into the early solar system. Take, for instance, the famous Halley's Comet, a celestial body that needs no introduction. It's not just its predictable return every 76 years that makes it remarkable, but the wealth of scientific discoveries it has enabled. From Edmund Halley's realization of periodic comets to the Giotto mission that gave us our first close-up images of a comet's nucleus, Halley's Comet has been pivotal in advancing our understanding of these celestial wanderers. And it's not just Halley's. Each comet that graces our skies brings with it a wealth of information, waiting to be unlocked, studied, and understood. They are not just chunks of ice and rock hurtling through space, but bearers of secrets, whispering tales of our cosmic past. By chasing these celestial wanderers, we are in fact chasing the history and mysteries of our very own solar system. Comets, the celestial nomads, have fascinated us for millennia. These icy wanderers, made up of dust and gas, traverse our solar system, originating from its farthest reaches. Their journeys, spanning thousands or even millions of years, offer invaluable insights into the early solar system and the origins of life. The next time a comet graces our skies, remember you're witnessing not just a celestial event, but a piece of our solar system's history. Don't forget to like, share, and subscribe for more captivating journeys into the cosmos.